Hello, YouTube. This is Umozo3. In the previous lesson, we basically reviewed a lot of advanced data structures, right? I basically created and reviewed some static methods, and we looked at different things that we could do with arrays, ArrayLists, linked lists, stacks, queues, right? And also sets. And then I sort of ran out of time to review hash maps, but we've been saying a little bit about hash maps in lessons 55 and 56. And I wanted to review maps or dictionaries in this video. And I also wanted to basically tell you some other things that you can do with collections, which include, array lists and linked lists, and maybe also stacks and queues and sets and maps. And also arrays, right? We've been talking about arrays for a long time, for about 40 or 42 lessons at least. And so there's actually some other things that we can do with one-dimensional and two-dimensional arrays. And there's some methods that a class called Arrays provides. And so we're going to study another important class in Java. There have probably been 30 or 40 important classes that we've looked at. But a good reminder, remember when we work with these important classes in Java, sometimes we have to import things, right? We saw that when we were working with the scanner class. We saw that when we were working with file writer classes, right? But import java.util. ArrayList, linked list, collections, iterator, stack, queue, hash set, and hash map. And then in this video, we're going to be talking about the arrays class. So go ahead and make sure that you have these 9 import statements at the top of your class. And then we were basically talking again about array lists and linked lists and stacks and queues and sets and maps. And we're trying to compare and contrast these data structures and figure out not only when we would use them, but also in those moments that it's best to use them, what is it that we can do with them? How do we create them and how do they work? And then there's also the collections class. And we've already, for several videos, we've seen examples of Collections.min of ArrayLists or linked lists, or Collections.max of ArrayLists or linked lists, Collections.sort of ArrayLists or linked lists. But there's other methods that the collections class provides, and we're going to talk about that in this video as well. But if anything is unclear to you about array lists or linked lists or stacks or queues or sets or map, or actually, if anything is unclear about array lists, linked lists, stacks, queues, or sets, I would encourage you to go back to previous videos. And in this video, we can review maps a little bit more. So in the previous video, think about a map function. So it's a static method that accepts 3 strings. And so it creates this method basically declares and initializes a hash map on 2 different lines. So it says hash map of type string integer my dictionary. And then it says my dictionary equals new hash map of type string comma integer. And so basically this declares that the keys in our map are going to be strings and the values in our map are going to be of type integer, right? These have to be object oriented. They can't be little ints, but they can be integer objects that wrap ints. And so we could say integer x equals new integer of a.length. Go ahead and wrap the length of the first string that was passed into the method. And then y and z could just go ahead and wrap the length of the second and third strings respectively. And we could go ahead and associate those key value pairs. So let's create those 3 key value relationships, right? So my dictionary.put of a comma x, my dictionary.put of b comma y, my dictionary.put of c comma z. And then integer w equals new integer of 400, my dictionary.replace of dog comma w. So what does this do? Well, it basically replaces the key value relationship, but there's no value associated with the key dog, right? We only added basically the key value relationships for ax, by, and cz, not for dog 400. So you would have to go ahead and study the functionality for the replace method. So you would go ahead and do hash map Java API, and we would want to go ahead and understand how the replace method works. And you could go ahead and look up this API. Hopefully you're comfortable doing this. But this replace method says replaces the entry for the specified key only if it is currently mapped to some value, right? And that would not make the assignment if it's not being mapped to some value already. So hopefully that's clear to you. But this would say and then we could say system.out.println of my dictionary.size and figure out how many key value pairs are in the dictionary. And you could say integer s equals new integer of 22, integer t equals new integer of 26, my dictionary.replace of b comma s comma t. So we know that b is one of the keys in the dictionary, right? It's one of the keys in the hash map, but this would only go ahead and replace the value associated with the key b. It would only go ahead and replace it and reassign it to t if the current value of b is s, right? And that's what it says here, right? replace of k key, v old value, v new value, right? And so that would only replace the key, the entry for the specified key if it's currently mapped to the specified value. And since that's not the case, it would not make that replacement. But you could go ahead and print out the size of the dictionary, so that would be 3, but it would not do this replacement, right? And then you could go ahead and say for string p in my dictionary.keyset, right? So this is another method that belongs to dictionaries. It's an instance method that you call in a particular hash map. And you could say system.out.println of p. So it would just print out the strings, the keys in the dictionary, right? And then you could also figure out the length of that string. So how would you do that? You would say my dictionary.get of p int value, right? So hopefully that's clear to you, because we're associating each of the strings, each of the keys with their lengths, right? That's what we said, my dictionary.put of ax, my dictionary.put of by, my dictionary.put of cz. And so if you say my dictionary.get of p, this would get the value associated with the string p. And then that would give us the int value, right? So the length associated with app, banana, and carrot, if we use those 3 string inputs from the previous video. And then we could also clear a dictionary. So you could say my dictionary.clear, and then you could figure out whether or not the hash map is empty. So you could say system.out.println of my dictionary.is empty. So hopefully that's clear to you, and we could go ahead and try that out with the main method, right? So we could say person.map function, we called it, and we're going to pass in app, banana, and carrot, right? Hopefully these string methods are familiar to you from lessons 5 and 6. So then if we go ahead and compile it, and then we go ahead and run it, it says 3, right? Because that would be the number of key value pairs, right? We tried saying replace on dog or something, but dog didn't have a value. So that dog 400 was not added to the map. But you would say app, length of that string 3, banana, length of that string 6, carrot, length of that string 6. Because we said that the keys have to be unique in a dictionary and a hash map, but not the values, right? So here we have basically 6 as the value for both of these keys, right? Banana and carrot have the same length. And then remember, we say my dictionary.is empty at the end, and that would return true. So hopefully after that review, the hash maps and the dictionaries are a little bit clear to you, but they're 2 different words for the same thing. It's a set of key value pairs. And if you say my dictionary.get of a, that gives you the value associated with the key a. So hopefully that's clear to you, and you can go ahead and study some more of the functionality of stacks, queues, sets, maps, array lists, or linked lists if any of that's unclear to you. What we're going to do now is we're going to think about collection. We're going to think a little bit more about the collections class. So you could do collections Java API, and we've already seen a couple of methods that pertain to the collections class, but I want to basically make you aware of some other helpful methods, right? So we've already talked about Collections.sort of array list or linked list, and Collections.min of array list or linked list, Collections.max of array list or linked list. But there's other methods in here. So we also have a Collections.binarySearch. So remember, in a previous video, we talked about the binary search method, and we said, like, for example, with a dictionary, like with an actual dictionary, like think about one in your house. If you were looking for the definition of the word potato, you know, you would basically keep flipping, and you wouldn't start at the beginning. You wouldn't do apple, you know, after aardvark, aftermath. You wouldn't start at the A's and work your way down. You do basically a binary search where you would flip somewhere in the dictionary, and then if the letter that you were at was less than P, right, was before P, then you would flip to the right, otherwise to the left. And that division by 2 algorithm is much more efficient than linear search, especially for large sorted lists. But anyway, we can go ahead and do a binary search on a particular array list or linked list. And as long as our class has a valid compare to method and implements the comparable interface, it's okay to sort a particular array list or linked list and then search for a particular element. And then we're also going to talk about a shuffle, right? So Collections.shuffle of a particular array list will randomly permute the elements in the array list or linked list, and just randomly, right? So you could go ahead and randomize the elements in an array list or linked list, right? But we can go ahead and look at some of the methods that we have available. And so we're going to talk about Collections.fill, Collections.addAll, Collections.shuffle, and Collections.disjoint, and then review Collections.min, Collections.max, and Collections.sort. So anyway, let's go ahead and scroll down. So I just have another method here. And so we're going to say collections class function, and it doesn't accept any inputs. We're just going to call it. But I have array list of type string, my collection equals new array list of type string. My collection.add of walrus, my collection.add of pig, my collection.add of butterfly, my collection.add of trout. So it would add those 4 strings to the array list, right? Simple enough. And so the element at index position 2 would be butterfly. The element at index position 0 would be walrus. And then it says system.out.println of minimum string but compared to would be collections.min of myCollection. And remember, if we're thinking about comparing two strings, basically the string class has a compare to method. And we think about comparing strings lexicographically. So the minimum string would be the one that would appear first in the dictionary. So presumably that would be butterfly. And then the maximum string would be the one that would appear last in the dictionary. So presumably that would be walrus, because W. And then if you say collections.sort of myCollection, that would basically sort the elements according to the compare to method. And you can go ahead and research for yourself that the string class has a compare to method. And like I said, it would be an alphabetical comparison. And then you could say, well, v is less than myCollection.size after initializing an int v to 0. System.out.println of myCollection.get of v, and then v plus equals 1. And obviously that would just iterate through the elements in the array list and print them after having sorted them, right? So then that would hopefully give us, butterfly, and then pig, and then trout, and then walrus, because that would be the elements sorted in alphabetical order, right? But you could do that with any sortable collection of elements, right? With person objects, or toothpaste objects, or car objects, or integer objects, anything that's sortable. And then we could say, could we find walrus with binary search, right? And then after sorting these elements, hopefully walrus would appear at index position 3, right? It would be the last element in the array list, right? And then we're also going to talk about this collections.fill. So if you say collections.fill of array list or linked list with a particular element, basically it would replace every element in the array list or linked list with the element you specify. So instead of having like butterfly, pig, trout, walrus, we would get dog, 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 because it would basically replace every index position with dog. And so if you said for string s in myCollection, system.out.println of s, so we would just get dog, 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 dog. And then we could add 4 elements at the same time. So if you say Collections.addAll of myCollection with fox, wolf, possum, and coyote, basically this is a void method that accepts a collection like an array list or linked list, and then any arbitrary number of arguments. So 4 arguments, or 112 arguments, or 19 arguments, but it would add those elements to the array list or linked list as long as all of those elements have the same data type as the array list or linked list, right? So if it's an array list or linked list of person objects, you would need to specify some number of person objects here. But then you would say system.out.println of newSize of array list, and then hopefully we would have 8 elements after adding 4 at the same time. And then there's also collections.shuffle. So this is another void method, but if you say collections.shuffle of myCollection, it would basically randomly permute the elements. It would basically totally just randomize the order of the elements in the array list. And then we can think about a do while loop, right? And so we can say do system.out.println of myCollection.get of counter after initializing an int counter to 0, counter plus plus, while counter is less than myCollection.size. And then there's also a collections.disjoint method. So you could also go ahead and see if 2 collections are disjoint. So I don't know how much you guys have studied about sets and things like that, but we basically say that one collection will be disjoint with another collection if they don't have any of the same element, right? And so this is kind of a silly one, but what if you said collections.disjoint of myCollection with myCollection? Well, this is a Boolean. It would return a Boolean like a true or false, but certainly this would be false, right? Because an array list cannot be disjoint with itself, right? But what if the collection was empty? So what if you created 2 queues, right? You declared 2 queues, queue of type string, empty q1, empty q2, and then empty q1 equals new linked list of type string, empty q2 equals new linked list of type string, and then you said system.out.println of collections.disjoint of empty q1, empty q2. So presumably that would return true, because 2 empty queues do not have any elements in common, right? And then you can go ahead and do different things with that, but that's just examples of the disjoint method. But then we can go ahead and run the collections class function, right? And then we saw butterfly and walrus, that's what we were expecting. And then it sorted the elements. And then it said that walrus occurs at index position 3 according to binary search. And then you can fill the entire collection with the dog element, right? That's what we did here. And then after we added 4 elements at the same time, there were 8 elements, right? And then it randomly permuted those 8 elements and printed those there. And then a collection cannot be disjoint with itself, but then if 2 collections are empty, then we would say that they're disjoint. So hopefully that's clear to you. And then for the last 5.5 minutes, I want to talk about some other things that you can do with arrays. So there's another class called Arrays, and you can go to blackle.com and type in Arrays Java API. And there's a lot of static methods that the Arrays class provides. But what we're going to do is think about creating two int arrays. So int numbers equals new int of 5. And we said that if you create an array in this particular fashion, it would go ahead and just create zeros, right? So it'll give you 5 zeros. But then if you say int values equals 29031, it would give you 29031, right? And then we can also think about a copy of method. So if you say numbers equals Arrays.copyOf values -2, basically, it would go ahead and create a copy of the values array. So it would go ahead and duplicate this array and reassign it to numbers. But basically it says that the new array is going to have index position -2, and you can't do that. So you would basically have something called a negative array size exception. And you would say can't have a negative length for an array. And basically it would instead say numbers equals array.copyOf values with 10. And so basically we would take this values array and get a copy of it and reassign it to the numbers variable. But then it would go ahead and pad it with extra zeros at the end until this numbers array has a length of 10. So hopefully that's clear to you. And then you could say system.out.println of Arrays.toString of numbers. So it turns out that there's actually a toString method in the arrays class, and it's a static method. So you don't call it on a particular array, you just call it on the arrays class. But you feed in an array, and it basically gives you a clean string representation of an array. So instead of needing a for loop or a while loop to iterate through the elements in an array, you could just say Arrays.toString of a particular array. And then there's also Arrays.fill, right? We also said that there was a Collections.fill, but there's also Arrays.fill of values with 2, 4, 6. So what does this do? Well, basically it will fill the element 6 into the values array, but only starting at index position 2 and ending just before index position 4. So then if we tried doing Arrays.toString of values after we filled the index positions 2 and 3 with the element 6, hopefully instead of having, 29031, we would have 29661 because we filled index positions 2 and 3 with the element 6. And then we have system.out.println of Arrays.equals of numbers and values. So basically there's an equals method in the arrays class, and it returns true basically if the elements at the index positions of those two arrays line up with one another, right? It's not good enough for them to sort of have the same elements. They have to have the same elements exactly at all the index positions, right? So the order matters. So this would return false, obviously, right? Because these are two totally different arrays that we're working with. But then there's also a binary search method for the arrays class, right? So just like with the collections class, how you could say Collections.binarySearch of a particular array list or linked list, comma, an element that you were looking for, you can do the same thing with arrays. And you could say system.out.println of Arrays.binarySearch of values with -200. And remember we talked about when we were talking about searching algorithms and when we were talking about in our YouTube videos about linear search and binary search, we said that those methods characteristically return -1 if an element does not appear in an array. And so the element -200 doesn't look like it makes its way into the values array. So we would expect -1 for this, right? And we would expect false for the result of this equals method on the previous line. And then if you say Arrays.sort of values, so like we said with collections, right? You could say Collections.sort of array list or linked list. You can also say Arrays.sort of values, right? And again, as long as you implement the comparable interface and make a valid compare to method like we did for the person class in previous videos, and like we did with the egg class in more recent videos, it's okay to sort the elements. You just have to define what that operation means. So you say Arrays.sort of values, right? But for primitive ints, sorting is pretty clear cut, right? And I think we know what it means for 5 to be less than 7, for example. You could say values equals Arrays.copyOf values with values.length -1. So what does this line do? So it seems like we're taking a copy of the values array and we're assigning it into the values variable. But here, the length of the new values array is going to be the current length of the values array -1. We're going to say Arrays.copyOf values with values.length -1. So it's going to shave off the one element. It's going to shave off the last element from values, but give us everything else in the array. It's just going to reassign it. And then we're going to say for int q and values system.out.println of q. So just a pretty clean for each loop there at the bottom, just so that we could see all the elements in the values array, right? But we said that we could also print an array with the Arrays.toString, right? but then we could say arrays class function can't have a negative length for an array, right? We saw that in the try except block. And then 290310000, right? That was the Arrays.copyOf with the higher length than was original, right? And then 29661, that was a result of calling fill. And then false, that was one of the results. And then -1, 1, 2, 6, 6. After we sorted the 4 elements in the array, there were 4 elements left. So hopefully that makes sense too. So for Mumos03, thanks for watching and please subscribe.